Stat A. 8.1.1, sampling distribution of sample proportions, day 1. Now, I know it is a handful in terms of amount. Now, again, what we're doing, we are now focusing on the notes. So I see a lot of you that are really going into your computer. Your eyes should be mostly up in here about what we are doing. So I need you to be focusing a little bit more. Candy, I need you to be focusing a little bit more up on the screens, not your computer screens and whatever's going on and watching. We need to be focused on here, especially as we're in a new unit, a new term, and a lot of what we're going to be learning in terms of this vocabulary and actions is what we're going to be doing for the rest of the year. So if you have gaps on what we are learning in these next week or so, that's probably going to end up hurting you for the rest of the year. And I'm not saying that lightly because everything is based on what we're kind of talking about right now. So first off, we have this idea about the proportion. So, well, first off, we have we want to make sure we understand the difference between a parameter or a population, sorry, versus a sample. So again, a population is everyone. So the population is first and foremost everyone in the population of interest. We also call this a census, right? So in a census, if we had everybody, we knew we could sample and we could ask everyone, there's really no need for any more statistics. If we were able to collect data on every single immigrant that was coming into the country, European or America, then we don't need a sample. We don't need statistics because we have pure information. But that's not the case. We don't. So we have a sample, which is a portion of the population. And what's more important is that we want it to be unbiased, which means that we want it to be random. Okay? So we want an unbiased sample. We want something to be random. We've learned earlier on in our course what it means to be random, different ways to take random samples, a simple random sample, systematic random sampling, cluster sampling, stratified sampling, a lot of different random sampling methods. So we have another thing called a parameter, and the parameter is it is the variable of interest from the population. So the parameter is the variable that we are interested in studying about the entire. Now, in this case, we call that like we were saying about the percentage. We want to know if it really is 60%. So what percentage of students or of immigrants are adult males? That's what we're talking about. That is called the parameter. Versus the other side, we have what is called a statistic. A statistic is an estimate of the population parameter from a sample. So sometimes you'll hear me say the sample statistic. You'll hear me say population parameter. Sometimes you'll just hear me say parameter versus statistic. What is the parameter of interest? What are we trying to study? Who is the population? Okay, so who is the population? It's the immigrants. The immigrants are what our immigrants are who we are trying to say, immigrants that are coming into the country. That's what we are trying to study. The statistic or the parameter being the true percentage or the true proportion of those that are young males. Now, today, in 8.1, our parameter is P. Okay, our parameter is P, which is the true proportion of, and I'm going to put this in quotation marks, successes from, or yeah, from the population. Now, I put those in quotation marks because the context is what's going to change. So what we're trying to study is proportion. And remember, a proportion, a proportion is, in other words, remember, like a percentage. All right, so when you hear proportion, you should think percentage. But we want to study it as a decimal. All right. So in the problem that we have that the true proportion, the percentage was 60%. So in our problem, the proportion is going to be what? What is 60% as a proportion? What is it as a decimal? 0.60. Okay. So instead of saying 60%, we're going to say 0.6. P equals 0.6. The true proportion is 60%. The parameter. Sorry, the statistic that we are going to be studying is P hat, and this is pronounced P hat. It is the sample proportion of successes from the sample. I guess I don't need to. It's the proportion of successes from the sample. There's no need to repeat the word sample. And P hat is equal to X over N. The number of successes, the number of observed successes divided by N. Okay? So really quickly, please complete slide 8. Which is the parameter? Which is a statistic? Yes. Those should be. Let me check. It should be, sorry, it should be, it says 3 groups, it should be 2 groups. Sorry. Yeah, it should be 2 groups. Sorry. I forgot to fix that part. No, I didn't have it. I didn't have it coded good. Let me see what you're doing here. No, you're off. Let me see here. Let me look in here. Who else has a try in here? There we go. Candy has gotten it. Yes. So the statistic is the what? Is p hat, which is called the sample proportion. The parameter is p, which is called the population proportion. The statistic comes from the sample. The parameter comes from the population. Very important to make sure that we understand those differences. All right, so let's look back to this right in here. I'm going to open up the next one. So we have, for an example here, we're talking about it within our do now, this idea of the United States, Trump, and Farage from the UK. We have some actual data. So the population parameter, again, here was our answer to the previous slide. The Immigration Citizens Survey conducted a random sample of database surveying recent immigrants to Spain who were 15 and older in Spain's immigration hub. The city of Madrid, in the city of Madrid, 257 of the 583 immigrants sampled were male. So what was the population? What was the parameter? What was the sample? And what was the statistics? All right, so who's the population? Who are we looking at? Who are we interested in studying? Huh? More specifically. So it's immigrants, but more so migrants. But more specifically, who are we interested in? Who was surveyed? All, you don't need the all was maybe not needed, but all migrants in Madrid who are 15 plus. All migrants in Madrid who are 15 and older. That's who the population is. So the parameter is P, okay? The proportion of Madrid migrants 15 and older, right? 15 plus. Who are what? What are we looking for? What is deemed a success? They're all immigrants. But what is defined as a success? What are we looking for? What are we trying to study about these migrants? Who are male. There it is. What we're interested in studying is what proportion of these immigrants in Madrid, 15 and older, that are male. Now, something to note here. Notice there's an issue in here that sometimes is a little bit overlooked. Tense of the word. All right. Notice I use the word are male. I didn't say who were male. I said who are male. In the population, we are looking for what do things look like? How are they? In the sample, we already know what the sample looks like, and so we have past tense or what it was. They were this. So in a sample, we use were in the population and who they are. So what is my sample? Who did I sample? More specifically, yes, I did cite immigrants. Yes. How many? 583 immigrants. My statistic is p hat. Now you can actually do p hat if you want to. I believe you have the issue. No, I don't know. They don't allow you to do it on this. You can just do p hat, p dash hat. And p hat in this problem was 257 out of the 583, which when I divide this gives me, ooh, there it is. It's already done the math, does it for me, 0.441. Just a little bit above, just about a little bit above 41%. If you do the 257 divided by 583 and hit equals, it shows you in the grade. All right, so that's my sample statistic, 0.441. Now, here's the thing about statistics, all right? And again, a lot of this is I'm trying to teach you is more so just understanding and common sense. So, and we're going to go to this. The belief is what percentage are male? What is the current belief? No, what is the belief? 60%. Okay, 0.6. We took a sample. My sample is 0.441, about 44%. 44% is what compared to 60%? It's less. Okay. So they think it's more than 60%. Our sample was less than 60%. What does that say to us? No. So, and this is the biggest thing that I have to teach you in this unit. It tells us that it is likely that there is evidence that they may be wrong. Our sample statistic is less than what they believe it really is. The question becomes, is this low enough to make an argument that they are wrong? Or could this 44% be due to random variation? Because remember, in other words, here, and this is what we do, is that result unusual? Is that unusually low? And this is what we do as statisticians. And again, I'm trying to get you to do this conceptually rather than just write it down and follow these steps, because when you get to college, you're gonna forget everything. So the whole thing is, all right, they believe 60%, a little bit more, it's more than 60%, 60 to 75, and we found 0.441. And so now we have to ask ourselves, oh wait, now a bad statistician says, my sample's lower, you're wrong, I'm right. It's not 60%. But the question that we have to ask, could it have been 60%? Well, yeah, it could have. By all intents and purposes, it could be, the true proportion could be 60%. And by chance, we just had a very low sample. Okay, that is possible. But what is the probability that that would happen? That if the true proportion is 60% males, what's the chance? What's the probability that I get this result? And that is everything that we are trying to study in this course. And that's basically the same. Now, of course, there's different situations, but that's what we are going to be doing. So really quickly, please, for your end, so that you know that what I'm doing, please match these all up. Show me in the card sort so that I can give you the credit. Match them up. That's mostly look good. You should have 4 different groups in this case. Not 2 groups, you should have 4 groups in this case. You look good, yes, yes. Sorry for not putting the recoding in. I spent a lot of times trying to gather the material in a way that would flow best I could. I've actually broken this lesson into 3 different days for you. And so I didn't double check on the coding to see most of the stuff was recoded to show correctness. All right, now we're going to come back to this question with here because I can tell you 583, that's a pretty big sample, right? 0.44 is quite a bit of ways from 0.60. So what this tells me from a statistician, and we're going to show you, by just looking at it, I can just feel that this is low. I can feel that 44% is really low and that there's something going on. We're going to put that. So we're going to practice and see what we're going to do, because what we have to learn is what's called a sampling distribution. So I have an activity for you, and you're going to do this, and then you're going to put